Hello, everyone, and welcome to The Cut. The Cut is the CERATIZIT YouTube show where we talk about exciting topics around the world of CERATIZIT. Today, we are going to be diving into the world of steel turning, one of the most common applications in the general engineering world, the machining of steels. I am joined today by two of my colleagues, Stefan Karl, a product manager by the Cutting Tools Division at CERATIZIT, as well as Kathtrin Weirather, who's a innovation manager from the R&D department of the Cutting Tools Division as well. So hi, guys. Thanks for joining me.
Hi, everybody.
Hi.
Hello, hello. Okay, great. So today we're going to dive into steel turning. Something that is a very common application in the modern machining world. Stefan, how about we start with you? Tell us a little bit about what are some of the challenges when it comes to the machining of steel?
Um, It's a good question. I think the best or the main challenge is to finding the right way of machining with the right tools so we can get the best possible performance for the process and for the application that we want to do. So when we talk about insert turning, it's not always easy to find the right insert for your process from the big variety of shapes, geometries, rates, and all that kind of stuff. So to supply the perfect combination for every customer application, it's the main thing about it. Especially in the largest material group, steel turning or material steel, there are so many different properties that we have to be absorbed in the cutting material. It's not easy to find the best option for the insert that we have or that we can offer to the customer.
Yeah, so I guess the diversity of the material and the multitude of different unique situations in which it needs to be machined definitely creates a challenge to providing the ideal tool solution for every one of those unique scenarios. Okay, so you mentioned steel being very, very common. Can you talk about like a specific CERATIZIT solution that exists for machining steel?
Yeah, we have brand new ISOP carbide grades from the up-to-date January this year, especially for machining steels. So we targeted this big material group steels and developed new grades for this application. These are designed in such a way that the majority of application steel group can be machined with them. So in addition to this, we have now installed an indication layer on the inserts which make it easier to check the cutting edges.
Wow, I mean, an indication layer, that sounds, pretty useful and like something that really offers, an additional benefit to end users utilizing these ISOP grades. You know, how does the idea or where does the demand for such an indicator layer kind of come from? I mean, the principle of it seems pretty clear to me, but maybe Kathtrin, you can talk a little bit about, why we would develop an indication layer like this.
Yeah, as the indication layer, the demand was from the market, from the customer, because yeah, black is beautiful, but sometimes it's very hard to recognize the wear or if the insert was in use because of the black color of the coating, or the it's under different light. It's very difficult to see it. And so the demand from the market and from the customer was that we create something which makes it easier to detect the wear on the insert. And so we focus on customer demands, and we develop a coating or a new range of grades to meet the customer requirements.
I mean, besides the indicator layer and the obvious benefit of being able to visually recognize which cutting edges have been utilized and which ones are still brand new, talk a little bit more about coating technology. I know it's something that CERATIZIT puts a lot of effort and resources into, and the coating is really critical for the performance of the tooling. Can you tell us a little bit more about the coating in general?
Yeah, of course. So the coating in general, sometimes it seems that there were no giant leaps in turning the last few years on the market, but except the free turn, but there are a lot of improvements which happen in the background and in the detail, and so also this new coating, because if we have a closer look on the coating on our inserts, we made a lot of improvements and innovations. For the ISO P series, we use a CVD multi-layer coating, and I tried to explain it in a very easy way. We use with a chemical gas process, so the real name is chemical vapor deposition, to produce different hard material layers on the insert surface, and they consist of crystals. And every of these layers has different properties and tasks. So the base layer, for instance, titanium nitride, is for reducing tensions, or layers of titanium carbonitride and especially aluminum oxide are used for insulation and for wear resistance of the insert. And compared to former grades, which just seem to be similar, we improved the orientation of the crystalline structure. And so we get more performance during the machining. And this is one of the secrets behind it. And like Stefan mentioned, on this new series, we add also a golden indication layer as a top layer. And so it's easier for the customer to check the state of the insert and if it's stamped or not. And this function of this top layer is more optical. But we remove this top layer, the golden top layer, with a mechanical blasting process. And so we had a great side effect that we smoothen the surface of the rake face. So the rake face is black color, and the surface of the rake, the flank, is golden color. And another good point of the coating is that on the rake face, it's very smooth, and so friction and also for the temperature can be decreased between the insert and the chip, and this leads to a higher tool life.
Wow, so it's really a combination of the many multitude of layers, as well as the grade itself, that, you know, all these factors play a huge part in the performance of the tool itself. And yeah, very fascinating to hear a little bit more about how those layers are put in place. Yeah, very, very cool. So we just talked a little bit about the coatings. Let's talk a little bit about the portfolio that CERATIZIT has to offer of tools and inserts to, you know, tackle the world of steel turning. Maybe Stefan, you could tell us a little bit about our portfolio of steel turning tools.
Yeah, the portfolio is also very important to compete with our competitors on the cutting tools market. It's always good that the customer can choose the right insert for his application, and it's we have to prepare this portfolio for our customers. So we try to make the selection as easy as possible for the machine operator and for a customer. And in the turning tool, it's composed of an insert and a holder, so it's a combination of these two. And with the inserts, we have 3 different grades for every machining situation. For example, a smooth cut or an interrupted cut, and combined with 3 basic chip breakers. These are offering a solution from finishing to roughing. So I think you know that. We have a fine chip breaker for very small cut depth of cut or feeds, and a stable one to go roughing and do very heavy operation with it.
Make some chips.
Make some chips, yes. And CERATIZIT has an insert to match for most of this application with these 3 grades and these 3 chip breakers. So in addition, we also offer special chip breaker geometries that can be also a problem solver. For example, a customer has problem with chip breakings. The chips are too long and do not fall into the machine room where they should be. And we take a look on this and can offer a different chip breaker geometry to break the chip more aggressively, so we can keep it shorter, and the application is more safer now. And the second part of turning tool is the holder. We also offer now direct cooling turning holders. In the up-to-date January this year, we offered the MaxiLock S with screw clamping. The good thing about these direct cooling tools is that we have a precision cooling on that heat zone that we have to cool. If this temperature is lower, we can go for higher cutting speeds, and in combination with our new grades, we have the opportunity that we can go for a better performance, because our new grades are working very, very good with higher cutting speeds.
Wow, it's really interesting, thinking about steel turning. There are so many variables and factors that play a part into it. I mean, it starts with the substrate. You think about the coating itself. Then you have the chip breaking technology to make sure your chip's breaking right. Then you have your holder and whether or not you have good coolant with a high PSI. It's so fascinating that so many variables play into this, to being successful in the world of steel turning. But let's focus a little bit on the coolant portion. We talked about how important it is to have coolant and to place the coolant at the right place, at the right time, at the right pressure. Kathtrin, maybe you can tell us a little bit about the design of the holder and the coolant functions.
Yeah, there are a lot of challenges in developing such tools and tool holders, but the main thing is that you create a simple and easy to handle tool holder, which is flexible for the different machine connections and the different coolant supply possibilities of the customer. And I think that's what we really made, a flexible holder for any requirements of the coolant. So means the focus was directly through the VDI adapter to the tool, but it's also possible with coolant pipes. But in developing, the biggest obstacle is the inside of the tool holder. That means a lot helps a lot. So that means we need to bring a maximum volume flow of coolant directly through the holder, through the coolant nozzles, precise to the rake face and the flank of the insert. And that's the secret to create the inside, all the channels that you have the maximum volume flow. And it's not so easy to put this in this very compact design of the tool holders, because the space is very limited. And furthermore, if you design it, it's not easy to manufacture it afterwards. So you need to manufacture it in an economical way. And here is also a real challenge for the production to find new ways to machine this tool holder.
Yeah, I can imagine. I mean, having complex channels to transport fluid from the machine itself directly through the tool holder onto the cutting edge at exactly the right spot, at exactly the right pressure is definitely a challenge in the manufacturing process, I can imagine. Yeah, but that's one of the most important things. And I know, we offer, you mentioned the VDI adapter with direct cooling, but as, we also consider direct cooling for like the monoclamp system, for grooving tools as well. CERATIZIT, takes the time to manufacture the right tool for the right situation, make sure that all those challenging factors in the steel turning world are met. Thank you guys so much for taking the time today and talking about steel turning, a very broad and complex topic within, machining as a whole. But it's cool to hear, how CERATIZIT approaches those challenges and that broad thing, and offer quite a, complex and wide solution to meet all the market demands for that. So thank you very much for joining me on The Cut. And yeah, we look forward to seeing our guests on the next episode of The Cut. So thank you, everyone. Bye-bye, and
Thank you.
have a nice day.
Thank you too.
Bye.
Have a good time.
Bye.